I can hear you, Bob, but the audience can't hear you yet because I haven't finished doing the introduction and switching you over yet. So, welcome y'all to Big C Live with PoE Texas. I have never gotten if I'm honest with y'all out there watching the live stream, I've never gotten so much sleep and eaten so healthy at a trade show ever before, and that sucks. I don't know about what you guys think. No dinners on expenses, nothing. And if we're going to have to spend the entire time at a trade show staring at a screen, then by golly, we're going to do our best to make it interesting for you by giving you great content. So we've gathered top experts in the world of PoE and asked them to do some quick 30-minute presentations on relevant topics about Power over Ethernet for intelligent buildings, including concepting, designing, wiring, networking, and creating wellness. I'll add a link in the chat and hopefully a card somewhere here while Bob and Dave are talking where you can see all the online sessions we're doing here at PoE Texas. Now, today we're going to be talking about cable infrastructure for intelligent buildings. And then later this morning, we're going to be talking to Matt Conger with Igor about how to take your intelligent building and maximize your IoT potential. And it's really a conversation about how to concept the building with your customer. So this morning, we have special guests, Bob and Dave with Siemens, who have agreed to show you the secret sauce for using cabling in an intelligent building. Bob will cover how it saves money and how you drive cost infrastructure, and Dave will show you how to do it well. So, Bob Allen, let me introduce both of our speakers today. Bob Allen is a lead green associate based in Watertown, Connecticut, and Bob is part of the Siemens Company team as the Global Business Development Manager for Intelligent Buildings and Strategic Alliances. In his role, he supports the global sales team to educate both current and potential customers on the converged IT intelligent building cabling solutions and the economic impact of intelligent building construction. Bob holds an MBA from the University of Hartford and has over 15 years of experience in the IT industry. One of his most recent accomplishments is being appointed Vice Chair of Continental Automated Building Association's CABA Intelligent Building Council. Though he has an impressive career in IT, Bob aspires to be a professional hockey player for the NHL. Let's welcome Bob to the show here in just 1 second. Now, Dave's going to have to make sure I pronounce this right, and Dave, correct me if I'm wrong. It is Dave Valentinakis?
Valentikonis, but that's close enough.
Valentikonis. Dave has corrected me. It's Valentikonis, and he joined Siemens in 1995 and has held positions in technical support and product management. He is currently the North American Technical Services Manager, where he manages an experienced team of product, application, training, and technology experts that help Siemens customers navigate a diverse and rapidly changing market. He is a Big C RCDD, NTS, an active member of TIA, and has a Bachelor of Science in Electrical Engineering from the University of Connecticut. So y'all, let's go ahead and welcome these two fantastic presenters to the show today. All right, guys,
thanks, Tyler.
We are live.
We're live? All right. Hi, everybody. Welcome to our presentation today on intelligent buildings and the infrastructure to support it. First thing I'd like to talk about is just kind of the trends that we've seen out there in the industry to lead us to where we are today and what has made the low voltage infrastructure so relevant. And basically, it really boils down to all of the systems in the building have now converged onto the network. Most recently, of course, being PoE lighting that we've been talking about now for at least the last 4 or 5 BICSIs. But now we're also, not only are we seeing these systems collapsing on the network, it's also allowing us to think differently about how we design our buildings and how we operate them. And I'm sure you're going to hear a lot of COVID talk on people's presentations this week. But if we look back 6 or 8 months ago, we probably didn't anticipate things like social distancing applications or UV disinfecting type applications within our buildings. And while things like that are deployable in legacy buildings, if we think a little bit differently about our buildings today and going forward and treat them more like an operating system, similar to the operating system in your phone that allows these apps to be more plug and play, it allows us to be a lot more economical in the deployment of applications that will help our business, help keep our people safe, and everything else that goes along with that. We're also looking now at situations where being able to bring all of those systems down onto the network allows us to take great advantage of an integration platform. And when we use an integration platform, we can typically save about $500,000 per 100,000 square feet of construction by eliminating things like proprietary software, making sure that the end user, the owner of that building, is not vendor locked for the life of that building, and give us the option of taking advantage of the open market during the operations phase. To show an example of that, here's a project that we were involved in Erie, Pennsylvania, where they wanted to build the most intelligent building in Erie, but they were a little bit over budget. So we met with the CEO of the organization and the architect, and with the help of one of our master systems integrators, and the architect identified those systems you see on the left. According to the architect, the cost to procure and deploy those systems in a more traditional model was just under $971,000. When we looked at using an integration platform and leveraging IP for all the different systems in the building, we were able to do it for about $481,000. We lowered the first-in cost, the capital costs or construction costs of that building by about 49%. One of the leading technologies that were deployed in that building was a PoE lighting solution. So where's this all come from? Well, the average cost in North America to bring AC power to the edge is about $1,000. We have a circuit breaker, a portion of the panel, a transformer, conduit, cable, and so on. We can bring PoE to that same location for about $250, figuring about $100 for a powered port, and then about $150 for an open air category cable run. So if you were to leverage PoE for everything that I'm aware of in a building, you'd add about 208 low voltage drops per 10,000 square feet. But keep in mind, every time we add a low voltage drop, we're eliminating an AC drop, and in most cases, an AC drop and a communication cable. So in doing that, the savings are about $156,000 per 10,000 square feet, or $1.56 million per 100,000 feet of construction. And looking at the savings by having everything IP and leveraging an integration platform, that's where we're seeing savings well over $2 million per 100,000 square feet of construction. So it is getting people's attention. It is changing the way that end users are thinking about their building and how the design teams are designing their buildings. We were recently involved in a project that wrapped up towards the end of last year, and they took this methodology as far as any customer that we've worked with. They wanted a PoE of everything type scenario, and in doing that, they had over 55,000 watts of PoE lighting, over 8,000 connected devices in the building, and I should mention it's about an 88,000 square foot building. Because of that, we used over 950 reels of Category 6A cable. There were over 100 different lighting systems and configurations in the building, serviced by over 60 PoE switches. And the lights came from 20 different custom lighting manufacturers. So we're really able to customize the approach. They wanted very high-end edge devices, and the market was able to deliver on that. So Dave, I think that kind of sets a good table as to why we're doing the intelligent building things. Let's kick it over to you so we can talk about how we best support them on the infrastructure side.
Okay, fair enough. Thanks, Bob. I'm going to try to share my screen now. I just need you to, there we go. I'm going to pop
share
up
quickly.
mine.
I made myself really big.
Okay.
Yeah,
tell me if you can see it.
There.
Can you guys see my screen okay?
Not yet.
All right. Let's see what we got here. Let's try it now. Share screen. All right. Let me know if that works.
No, we're still seeing Bob's handsome face.
Oh my God, that's, well, not that there's anything wrong with that. I don't want to judge.
So, Dave, I'm trying to pull it up on mine too, just as a backup. So keep working on yours.
I got it here. How's that?
Where'd I go?
Okay, well,
There we go.
we're seeing your PowerPoint, but we're not seeing in presenter mode.
There it
we
is.
go.
There we go.
Now
How's
we're
that? All
presenting.
right. So I'll pick up where Bob left off and really talk about, what he had some great messages there as things transition over to IP. And so when you're especially implications, everything going over IP is usually taking advantage of remote powering. So, but there are implications associated with that. So I won't spend a lot of time with this because I think a lot of our audience is familiar with the remote powering, but it's really kind of taken more of an impact as we introduced types 3 and type 4 PoE to really start thinking more and more about the implications for the structured cabling on that. When you deliver power, obviously you're adding heat, and there's a lot of, I say there's a lot, but there's a manageable number of implications that we'll want to talk about today to make sure that you're properly prepared for it, and then figure out some ideas on how you can address that during the installation of this low voltage cabling. So the primary things that we're going to deal with is obviously the heat buildup within the cabling as you add power to the communications in addition to that. But we can do things, we can manage the length, we can reduce bundle size, and we'll talk about that. And then there's the connectivity element when you're disconnecting from powered connection, and also how you can address that. So we'll walk through that as well. So when you talk about temperature rise of the cable, because you are introducing power in addition to the communication there, you're going to typically get a heat rise associated with that. Now, when you were actually talking about the characteristics of structured cabling, the insertion loss is actually evaluated about 20 degrees C or 68 degrees Fahrenheit. Now, a lot of your environments are going to be warmer than that, and there's going to be additional heat buildup in your cable. So the impact of that has to be managed from how much you allow for the heat buildup, and then what can you do to offset the implications of that, especially from an insertion loss perspective, which is what we're most concerned with. Now, you also don't want to exceed the jacket rating of a cable. And we're not talking about a situation where cables are going to spontaneously combust or melt or anything. As entertaining as that might be, it doesn't sound like the safety things that Bob would like to see in an intelligent building. So it's really just talks about if you're going above that consistently, you're going to degrade the cable, beyond what the expected lifespan is in terms of its overall construction. So we want to make sure that typically you don't exceed cabling above 60 degrees C, which is about 140 degrees Fahrenheit. And what you're seeing to address that is that's what typically cables are rated to, but you're seeing more constructions come out now that have higher jacket ratings, for example, 75 degrees C, to address specifically this heat buildup. So what happens is, depending on the amount of current you apply, whether it's type 1, which is the 15 watts, type 2 or 3, which we're talking 30 and 60 watts, or type 4, which gets up closer to 90 watts, you have a temperature rise in the cable bundles, and it changes depending on the category of cabling. So category 5E, for example, is less tolerant of it because simply it has smaller conductors of all of them. As you go up the ladder, you go to category 6, category 6A, category 6A shielded, and even category 7A, which is a fully shielded system. It has the ability to manage that heat dissipation better over that the length of that cabling run. So ultimately, what you end up with is that you have to have a certain level of derating if you're addressing temperatures to go up to 60 degrees. And when we say up to 60 degrees, we're assuming an ambient temperature of about 45 degrees C with a heat rise of about 15 degrees C, which gets you up to the 60 degrees C, which is the typical jacket rating of these cables. So if you look at these types of things, you see that along the way here, if you were in an environment like that, you would actually have to reduce your category 6A UTP cabling up to 18 meters at 60 degrees C, which is significant in a 100-meter channel. That's about a 20% derating to address and manage that insertion loss. If you bring it down to a category 6A shielded system, that comes significantly drops from 18-meter reduction to a 7-meter reduction. So certainly more manageable for doing that if you're aware of how to design your telecommunications rooms and distributing your cable plant to keep within that overall 93-meter channel. And then we actually have some properties within our Siemens category 6A FUTP cable construction that allows that derating to be limited to only 3 meters. So now you can have up to a 97-meter channel, even in the worst case scenario. And keep in mind, that worst case scenario may not be day one when you're maybe doing a few devices with PoE, maybe it's only type 1, type 2, but your infrastructure is designed to last for 10, 15, 20 years. And by then you can imagine there's going to be more devices that are going to be running potentially at higher PoE levels. So you want to start planning for this now and not when it becomes a problem. And certainly when you get to something like Category 7A, which is not as common in North America, but is used globally, it's a fully shielded cable, which means it's individually shielded pairs with an overall braid. And that actually has no derating up to 60 degrees C. So I think it might become a medium where people are going to consider something like that to take out the heat rise effect, knowing that you can still terminate that, for example, on a Category 6A shielded jack to give yourself a Category 6A channel that doesn't require any derating along the way. Now, when we talk about connectivity, what really comes into play is when you have a power device, there's always a handshake. It's never delivering power from the PoE switch to the PoE device until it actually has a handshake. And once it has that handshake, it's going to operate as usual. So the only situations where you're worried about this arcing under load is if you disconnect a live port from the end device. And what are the implications to your structured cabling on that? Well, if you unplug it from the jack side, the patch cord may be running from the outlet to the end device, and you unplug it from the jack side, you can actually create damage to the contacts over time. So because there is a small spark gap that's created as a result of that. So that can actually kind of reduce the performance of your connectivity from a physical perspective, as we've shown in the illustrations here. Because what you're really factoring into play here is when you have you have a mating situation. As soon as that plug makes contact with it, and then you have ultimately you have a final position where the plug and jack are fully mated, and you need to make sure that especially where that plug and jack are fully mated, that you don't have damage on both sides of the contact there that you might get along the way. So we see on top is kind of a standard legacy RJ45, just has straight contacts. And it gets a little bit of damage. If it gets damaged when it gets disconnected on the plug tip, well, look, that plug tip now is sitting at a point of damage. Even though the jack contact is not damaged in that area, the plug tip is. So you can have some erosion and kind of intermediate issues. On the bottom, it shows a crown contact design where you're still going to get damage on that plug tip and even at that point on the jack contact where it disengages. But when it's in its fully mated position, you can see it's at an undamaged location. And it's important to consider that. And, there's actually some IEC test specifications that connectivity can be tested to that ensures full compliance with these mating and unmating cycles. There's two specifications, one that addresses PoE types 1 and 2, and the other one that references PoE types 3 and 4. So when you're looking for connectivity, you just want to look for something that has been tested at that to confirm you're going to be okay, not only for today, but also in the future. So next step that I want to talk about that's come into play with a lot of PoE devices, as Bob mentioned, these PoE devices aren't computers or phones or something that's simply at a workstation. These are devices that are on a wall or perhaps above a ceiling or mounted in the ceiling. And as a result, they're not always suitable for a location to have an outlet and a patch cord. And obviously, it's good that if there's benefits to having that, we don't want to move away from that. It's great for administration. It gives you a little bit more flexibility in terms of moving cabling around in the future for different devices. But what they realized is that there is a need in some cases, even though it kind of goes against the structured cabling rules, to terminate the end of your horizontal cabling in a modular plug and just plugging it into the device. And it's really the rise of these IP tied devices that led to this type of situation. It's really designed for being by exception, but there's kind of been a fairly reasonable market uptake in that simply because of the mounting limitations for putting an outlet nearby. So when you think about some of these devices, whether they be wireless access points or security cameras or building automation systems or time and alarm systems or time and attendance systems even, we see people migrating toward that. And it is a recognized topology within the TIA standards. But one thing that we'd want to consider here that we really want to talk to is that if you're going to do that, you lose some of the flexibility at the workstation end without having an outlet in terms of if that device moves a little bit or if you want to repurpose that cable for another IP device. So in those cases, the consolidation point kind of something that you should really consider to bring back into play. And I think folks remember consolidation points from the days of open office cabling, where you might have people moving workstations around or workstations being reconfigured. And the concept was to introduce a consolidation point there because it made the move add chains easier, right? Because you're installing permanent cabling from your telecommunications room out to your consolidation point. But from there, you have the flexibility of doing shorter runs that are less disruptive to your end devices. So the same concept kind of applies as you work toward intelligent buildings, gives you a lot more flexibility because you don't know how many more devices you're going to be adding from an IP perspective. So designing the infrastructure from the telecommunications room to the consolidation point properly day one will give you that flexibility. And then as devices change and move, you really limit the disruption and the cost of doing some of those moves. So the combination of these two, I'd say if you're using one of these modular plug terminated links where you have a plug at the end of the device, you should always be using a consolidation point to help manage that infrastructure and not really let you get away to become more of a point-to-point cabling scenario. So how do we address some of these PoE rises? Well, TIA had issued a TSB, which is a technical service bulletin in 2018, which are for informational purposes. And it really talked about how do you manage that. And we talked about the heat rise going from 45 to 60 C. And what the summary was and the recommendations here is basically, and it's larger conductors and shields help reduce heat dissipation. And the larger conductor one is kind of more intuitive. Bigger copper, bigger pipe makes it easy, less heat buildup. But shields is something that I think a lot of people didn't really give much consideration to, but it's surprising the impact of that. Now, keeping in mind that when you're designing that and selecting your infrastructure, et cetera, you're looking at the worst case 1 meter segment of that entire channel as a basis for what you're going to do and how you're going to bundle and consider some of these types of things. So the mitigation recommendations for managing remote powering are actually kind of simple. It's a twofold approach. You just use the largest conductors you can, which in North America recognized is category 6A or higher. I guess if you wanted to talk about maybe, I don't want to get into it, but a category 8 cable that's really a limited application use. But the 7A is something you could use in North America that's a larger gauge. We're talking like 23, 22 gauge, and then install shielded cables. And if you don't do any of that stuff or you need to, you have to reduce your overall channel length. So if you put those two together, the message behind the message is category 6A shielded cabling is the best you can do for managing remote powering as per North American standards. Now, other ways that you can, that's kind of from the media perspective, but from the installation perspective, how else can I help dissipate this? Well, one of them is to reduce those cable bundle sizes. And it's not so bad when it's kind of out near the work area and the pathways, whether it be the J hooks or the basket trays. But as you get closer to a telecommunication room, those bundles increase and increase and increase, even within the room itself. And what they found in the studies is if you take those bundles and you reduce it. So an example here, it's 90 cables. If you took those 90 cables and reduce them into 3 groups of 30 cables, it reduces the heat on the center cables by 25%. Further, if you add an inch of separation, it reduces the heat on those central cables another 30%. So, it's simply moving away from those big bundles and getting away to more managed bundles is a good thing. What we typically recommend is limit those cable bundles to 24 as they come back in. Why? Because that aligns with your patch panel counts. It's an easy number to remember. And as you'll see on one of our cable dissipation tables, it kind of matches the number for what you can do with category 6A shielded cabling, the allowable cable bundle sizes. So this here is a manufacturer guideline. This happens to be Siemens. A lot of manufacturers may have it. It talks about the bundle size, the maximum bundle size for different media types as you go from the top of the screen, which is type 1 PoE, all the way down to type 4 PoE operating at that 60-degree limit that we talked about. So actually getting up to 75 degrees C overall with the heat rise. And as you can see, for category 6A shielded and category 7A, that magical number of 24 applies. Keeping those 24 cable bundles makes a lot of sense. Even if you look at type 4 with a maximum ambient temperature of 45 degrees C, which is, I think it's suitable for many customers, you can get up to 24 cable bundles even with category 5E and 6 and 6A UTP as well. So that 24 is a good number. If you just don't know, it's a great general practice rule to just apply this across for your designs, and then you don't have to have as much consideration for the rest of the installation. And then there's also a TSP, another technical service bulletin that talked about the use of 28 gauge cords, which have come out in the last couple of years, the smaller diameter patch cords. The only problem is their findings were to effectively do that, keep your bundle sizes to 12 and keep them 1.5 inches apart. And I think that's a great engineering practice, but I don't think that's a great practical practice. As you know, if you go into your horizontal and vertical management, it's really not practical to bundle those cables and keep them 1.5 inches apart. So I would say at the very least, try to limit your if you're doing 28 gauge cords in a PoE application, try to limit your bundle size to at least a group of 12. That's certainly going to help. And between some of the randomness and the pathways and the cable, maybe Velcro cable ties, you'll be able to achieve some level of dissipation there. And then finally, within the latest, there was an addendum to the TIA 569 Pathways and Spaces standard a few years ago that's been incorporated into the newest revision E that came out this year that really looked about, how do we address this remote powering from a pathway perspective? And what they came up with, the things that are frankly mostly intuitive, right? So the first one is when you get to pathway types and the ability to dissipate heat, non-continuous pathways like J hooks are the best at dissipating heat, right? They're hardly even come into play in your pathway at all in terms of containing bundles or not allowing the cables to have access to open air. As you get into conduit pathways or closed pathways, obviously they have a very, very low capability to do heat dissipation because these cables just don't have the ability to breathe in there. There's just not access to the open air. When you get to the bottom there and you talk about ladder trays, which are really right behind J-hooks is the best option available. Obviously open wire mesh basket trays are the best, but you could have a solid ventilated cable tray, which does okay, and you can have an unventilated, just straight up solid ladder tray, which is kind of the worst of the open system. So a lot of these things are be intuitive. When you're thinking about pathways, you're trying to avoid the conduit where you can. You want to go to as much of a mesh or J-hook pathway as you can to allow access to that ambient air and allow those cables to dissipate heat just through their space. So just wrapping up here, if we look at some of the categories in, from 5E all the way up to 7A, I've applied some just baseline kind of costs from a materials only perspective. And when you consider materials are only a small percentage of the overall cabling installation, when you think about the labor to install, terminate, test, administer, all that sort of stuff. So you have to kind of take the data with a grain of salt, but I just want to put it as a relevant point here along the way. But when we've put a lot of factors in here, everything from cable OD, termination speeds, et cetera. But the key to start thinking about as it relates to PoE as it is starting with heat dissipation. And as you can see, and you expect from category 5E being the worst all the way up to category 7A being the best, simply because of introduction of shields and larger conductors. So the lengthy rating goes hand in hand with that, where you have the ability to do less lengthy rating as you get better with the cables. And these bundle sizes are the ones that we talked about in a 60°C environment where the heat dissipation goes up. And because the heat rise allows it to get up to 75°C, and you really can't support that with category 5E or 6. So just some food for thought in terms of weighing these things, which is really why we talk to our customers and say, even if it's sometimes unless it's a low speed, low power application where you don't ever see that to change, you really should be thinking that if it's either high speed or high power, to be thinking about category 6A cabling, again, for the life of that cabling system, for what it's going to support, not only day one, but year 1 and year 5, and maybe even year 10, depending on your infrastructure. It's got the best capability of supporting higher speeds. Category 5E and 6 are a gigabit per second application, so 1 gig. Category 6A supports full 10 gig and beyond. So that's what you want to consider for bandwidth when you think about applications such as Wi-Fi or DAS that may use some of these higher speeds. So we have some additional guidelines on our website at Siemens.com where you can learn more about this kind of stuff. But with that, I will wrap up for today and turn things back over.
Whew, Dave and Bob, you guys are fast talkers, my friends. You get it done. Hey, well, we're right at our time. We're used up 29 of our 30 minutes, but I do want to ask a couple of quick questions for you guys right now. And by the way, everybody out there watching, go ahead and submit your questions for Bob and Dave. They're the experts in this. I want to know a little bit. I know zone cabling is a thing, but where does zone cabling really come into play with this building, PoE automation and intelligent building?
Yeah, I'll take that one. And actually, the challenge is that the intelligent building is still a lot of unknown for some people. So you're trying to cable for something that you don't really know how much it's going to apply yet. Now, as IP-enabled applications roll out, you can certainly add more switches in your closet. You can add more cabling from your telecommunications room out to these devices, and that's all well and good. But there is a disruption and a cost associated with that. So with structured cabling, you're trying to get ahead of this and really get a good solid infrastructure that's going to last you a fairly long time. And it depends on if your facility is a lease or if it's an own. A lot of those things may come into play, but getting a fair amount of quantity of cabling from your telecommunications room out to your zone box day one to allow you to get some of these devices. As Bob mentioned, sure, it was voice over IP and security cameras, and now it's PoE lighting, but we know it's more and more trends are going to move toward this IP-enabled technology. So you don't want to have to keep going into your telecommunications room. You don't want to have to keep going through the space between your telecommunication room and those devices to install more cabling, especially if you're like here in a manufacturing environment. I'm in an office here, but we have very high ceilings, so it's very difficult to install cabling cost effectively. So getting that decent infrastructure between your telecommunications room and a zone box really prepares that space to have that flexibility and future proofing to add a device here, add a device there as they become more IP enabled with less disruption. So it's a little bit, I would call it an insurance policy of sorts, because you're going to pay a little bit more to get that infrastructure between your telecommunications room and the zone box in place up front, but you're going to save that on the back end as you add devices down the line. So maybe you're not, obviously if it's a greenfield construction, you're going to be thinking about PoE lighting, and you wouldn't probably have to upgrade for that later. But you expect more building automation systems, especially, to become more prevalent. It's possible with Wi-Fi going to higher speeds, they're going to require greater density, so that more drops required for some of those. So it's an insurance policy, if you will. And honestly, it's just a good practice from design perspective, because it's not like the days of old where you had workstations and it was a finite amount of cabling. It's a little bit of the unknown. So just gives you the flexibility to plan ahead and really just be prepared if you have plans to have an intelligent building.
Makes your building plug and play, right? You can add devices as we go. And you mentioned you do PoE lighting from the beginning, but it's likely that at some point you're going to be adding a light fixture or reconfiguring light fixtures based on the use of that space. It makes it very easy and cost effective to do that.
True.
And I was going to ask you guys, how do you justify it to the owner, right? Because I'm sure every cable installer is like, heck yeah, I'll install more cables and I'll install more equipment. But the real idea is the owners have to decide it's the right financial investment. So what can the installers and the cable guys tell to the owners that is the justification and the reasoning? We've heard the insurance, but ROI is king. Do you guys have, what would you tell to your installers?
Yeah, well, if you go back to the beginning of the presentation, we're talking about leveraging things like PoE and the fact we can save over $2 million per 100,000 square feet of new construction. The cost of running a few extra cables is really an insignificant number. When Dave says we're cabling, providing additional cables, we're really looking at, in a 24-port zone enclosure, kind of planning original port density to maybe 22 ports of that zone enclosure. So we're really maybe only running 2 to 4 per enclosure that we may not be using day one, to provide that flexibility as new applications come out, as the needs of the building changes, tenants change, uses change, and so on.
Yeah, it becomes a little bit of a CapEx, OpEx kind of discussion, perhaps. If you want to invest a little bit more in that CapEx day one, you can get yourself a lower OpEx down there. So it depends on the model. You're right. I mean, depending on how you budget, but I find it's usually a lot easier to get an approved budget day one than to keep coming back for money in year one, year two, every time a new technology is released. So it could, I'm guessing, if you're a CTO or a CIO, you're gonna look good as this building progresses over time, because it's not really if the building becomes intelligent, it's going to become intelligent over time, I think, whether you're planning for it or whether you're not planning for it. So having yourself prepared up front is a story to tell. And I think a lot of cases it's not so much of an issue with the installer. We have these discussions with the consultants that are doing designs. More importantly, we have discussions with end users, but ultimately the customers is paying the bill for that. And so that's where Bob spends a lot of his time with those customers, having those conversations up front, really just to prepare them for it. So getting buy-in, it really depends on where they are financially, but I think most people understand it's coming. So if they're willing to do the little bit of CapEx now, like we said, and that little, it's not like we're adding more zone enclosure, we're adding more cables to the zone enclosure. And the big picture of an infrastructure for, say, a floor or a wing of a building, when you factor in the labor, those added cables are not that significant to the overall. And that's the time really that you're going to be in there when the spaces aren't populated. It's when the spaces are populated that you're usually having to come in and add these cables and do this work overtime, which is really time and a half versus the straight time you're going to pay day one to cabling to that zone enclosure.
Fantastic. Well, guys, we have taken an extra 5 minutes, and I appreciate it. And I'm going to wrap us up, tell everybody to meet you guys over at the Bixie booth. So let's go ahead and switch over. Thank you, Bob. Thank you, Dave. Appreciate it. You guys have been fantastic, and I really appreciate their time and the presentation today. I learned a lot. I was taking a lot of notes. Now, Bob and Dave are going to be over at our Bixie booth here for the next few minutes, ready to take chat questions if you want to ask some questions. Hit him up with a tough question. One that I wanted to ask, but I didn't get the chance to ask him is, there are people coming out with Cat 5e cable rated for high-powered PoE, but they told us to go Cat 6. Why? Now, I don't want to spoil it for them, so check them out on the chat line over at Bixie. And if you don't have a pass to go to Bixie, don't worry. I'll throw in the chat a free pass where you can register and see all the other presentations today we're doing. Later today, we're meeting with Igor about maximizing your IoT. We are going to also be talking about networking for intelligent buildings and power with Louis Saus, ex-Cisco executive. And we're also going to be talking about wellness and leads with Somfy and motorized blinds and shades. So that's all coming up. Don't miss it. So we'll see you in about 2 hours with Igor. Y'all have a great morning, and we'll see you over there on Bixie.
Thanks, Tyler. Thanks, Dave.
Thanks, guys.
Thanks, Dave. Thanks, Bob.
I thought you were going to say the hard question was, do we go to the same barber?
I'll see you on the other side.